Okay, here the recording in progress, so we'll share the screen. All right, we're getting near the end, folks. We only have 2.5 weeks left, less than a month until we're completely done. All right, just quick words about the exam. So you should have gotten an email reply back from me on the exam. If you didn't, let me know. Remember, you have to submit the homework. So if I didn't get any homework from you, I didn't grade your exam. You have to submit the homework at least 70%. And I sent a video on the solutions also. Okay, so if you didn't get your exam score from me or if you didn't get the video, please let me know right away. Okay, we're really getting near the end. So all we have left is chapter 6. We don't even do the entire chapter. 6.2, 6.3, 6.4, 6.7. If I take 2 days per section, that'll land us just perfectly. Okay, so 6.2 this week, it's on the parabola. So today's and tomorrow's on the parabola. Your quiz will be on the parabola. Please notice the quiz this week is on Wednesday because Thursday and Friday we're off for Thanksgiving. Okay. So this is on the parabola. Then 6.3 is on something called the ellipse. You don't have to write any of this down. Or if you really want to look, you can check the book on it. 6.4 is on the hyperbola. So take 2 days for that, 2 days for that. So parabola, you don't have to write it down, or I'll give you what you need day by day. The ellipse, hyperbola, and then something called parametric equations. Okay, now that being the case, I think we'll be finished with plenty of time. So let's go ahead and set the original date of Thursday, the 9th for the exam. At the beginning, I was waffling between, I'm going to have it Thursday or Friday. Let's aim for Thursday. And I'll only push it back if I find I can't finish everything. So let's aim for the exam 6 on Thursday, the 9th. Okay. However, I'm not guaranteeing I'll give you back your exam by Friday, but I'll give you at least a video. And when you get down to it, you don't really need to have your exact exam. All you need to study for the final exam is the video, right? So that means Friday the 10th, our last regular day, will just be a question and answer session. Just let you ask questions about anything. And then the first day of finals is our final exam, Monday the 13th, from 8:10 to 10:40. Please notice the starting time is 8:10 for that particular day. Okay, and then we're done. Now, I'm supposed to go ahead and tell you, although I know it doesn't really make a whole lot of sense for us, since we would have already been done with the final, but I'm supposed to announce office hours during the week of final exam. So there it is. Okay, so my office hours during finals week on December the 14th, 15th, and 16th are Tuesday, Wednesday, Thursday from 8:10 to 10 a.m. There's even a different Zoom session link for that. So you can't use a regular link. I have to give you the link for my 8 o'clock class. Okay. I'm guessing most of you don't have any reason to come during office hours because we've already finished the exam, but I'm supposed to tell you. Maybe the best way to say it is if you really want to catch me during office hours during finals week after you've already taken the final exam, then let me know ahead of time. I'll give me a heads up, then I'll give you the link for that. You can always email me once the final exam is over. And there we go. And again, to study for the final exam, just go back and review the previous exams. So look over the video for all the previous exams and maybe that weekend, that's how you would study for the final exam. Okay.
I'm a little confused. What days? Because we have class up until it looks like until the final. So, but that time interferes with our class session. So I'm a little confused.
Which you talking about this?
The 8:10. The 8:10 to 10 a.m. Tuesday, Wednesday, Thursday, 12:14. Oh, I see.
It's finals week, so the last regular day is the 10th. So once finals week begins, it's all different. You just follow the final exam schedule, and the final exam schedule for us is 8:10 to 10:40 on Monday the 13th, and we are finished. Okay, so we have no other scheduled meetings, okay, except my office hours that I'm required to tell you. Again, I'm guessing most of you won't want to come to my office hours, after you've already finished the final, but you can always email me, I suppose. So that's what's happening. Okay. All right, so we're getting near the end. We're going to do the parabola this week. And please notice the quiz is on Wednesday this week. Thursday and Friday we're off for Thanksgiving. And then once that hits, after Thanksgiving, acceleration comes so quickly in terms of the holidays and all that kind of stuff. So here we go. Okay, any other quick questions before we start? Okay, so we're doing the parabola. The main emphasis for this week, parabola. Okay, so 6.2. Page 320. There's a formal definition of a parabola. I'm not holding you responsible for it. Okay, there aren't any questions on the homework or test or quiz about it, but just so you know where it comes from. It's a very formal definition of a parabola. A parabola is a set of points in a plane that are equidistant from a given point called the focal point. It's actually more commonly called the focus, and I'll call it the focus, and a given line called the directrix that does not contain the focal point. Okay, the axis or axis of symmetry is a line that goes with the focal point and is perpendicular to the directrix. Okay, the point of intersection of the axis and the parabola is the vertex. Okay, so what are they talking about? Okay, so say, oh, I know what parabolas look like. Sure. Okay, there's a very formal definition though, based on a point and a line. The point is called the focus or focal point and a directrix. Now, if I pick a point in a parabola, I'll show you an example. The distance away from the focus and directrix is the same. This is the axis, sometimes called the axis of symmetry. You can tell that you have symmetry with respect to the axis of symmetry, right? The mirror image right there. Okay. Here's a point in a parabola. And do you remember this notation from high school geometry, perhaps? 1 mark, 1 mark. That means the distance from the focus to the directrix is the same. This point is on the parabola because this distance matches this distance. But let's take a point way out here on the parabola, right? And just put it, then this distance is the same as this distance over here. Okay, so that is what makes up a parabola. Right, so they give you some examples here on page 321. Okay, vertex that we're familiar with. This looks like y equals, kx squared, something like that. Okay, but here's a point in a parabola. This distance and this distance is the same. Here's the vertex. This distance and this distance is the same. Here's a point way over here. This distance and this distance, whoops, is the same. Okay, I pick a point way out here. The distance from there to there and the distance straight down to the directrix is the same. Okay. Now, the text goes over the derivation of it. I'm not holding you responsible for it. You can look at it or not. Okay. But I definitely do not want you to use this. Okay. If I say you end up using this, I'm not going to count it. You've got to do it my way. Okay. I think my way is easier. There's nothing wrong with it mathematically. It's correct. But I think the formula is much more convoluted than you want it to be. Okay. So do not use this. So if you use this on any homework or quiz or test, I'm not accepting it. You got to do it my way. And it's not really my way. Most other books do it the way that I'm going to show you. Our author has decided to deviate from that. Okay, so I'm going to show you what I want you to do. So here's my version, the Melvin Hom version, I guess. Okay, again, you don't really have to write any of this down if you don't want to, but I'm not testing you on it. But again, to highlight, a parabola is a set of points equidistant from a point, focus, call it F, and a line called the directrix. We'll use little d for that. Okay, so here's a parabola which opens up. Again, using the notation from high school geometry, perhaps. 1 mark, 1 mark. Here's the vertex. Same distance from the focus and directrix. Here's a point on the parabola. 2 marks, 2 marks. The distance from the point to the focus matches the distance straight down to the directrix. Okay, and here's a third point. 3 marks, 3 marks. This point is on the parabola because this distance from here to here matches this distance from here to here. So the distance from any point x comma y to the focus and the directrix are equal. Okay, so now there's going to be 4 basic kinds of parabolas, 4 standard kinds of parabolas. You can put all these on your formula sheet if you want. Okay. The 4 basic ones, as you might guess, are the ones that open up, for which you're very familiar with. Open down, also somewhat familiar, but maybe less familiar. Opening to the right, opening to the left. Okay, so here are the characteristics of each one. You can write this down, or you can watch the video and catch it later. Okay, parabola that's opening up. Okay, here's the form that I want you to use. X squared equals 4py, where p is the focal distance. Okay. So this is mathematically equivalent to what the author has here, but I don't like it. One of the reasons why I don't like it is you have a fraction, right? Why have the fraction when you don't need it? Okay. So I want you to do it my way. It's not really my way. A lot of other books use this. So a standard form for a parabola opening up. And right now we're doing vertex at the origin. Okay. If it's not at the origin, we know what to do, like this, right? Translate 1 left, 2 up, and all that kind of stuff. So p is the focal distance. X squared equals 4py. An easy way to remember is that looks like y equals x squared. Okay, you say, oh yeah, that is a parabola opening up. You can put all these on your cheat sheet, but a heads up, if we were meeting face to face, the last time I taught this, I'd make my class memorize it. So be that as it may. And maybe your next teacher, your next math teacher, which presumably is calculus, they might make you memorize it. So just thought I'd warn you about that. Okay, so if p is the focal distance from the origin vertex, I go p units up, so the focus is 0, p. And I go p units down and draw a line. The directrix is a line, y equals negative p in this particular case. Okay, so quite often in the homework, you'll be asked to give the focus and the directrix. Okay, notice that the focus is always on the inside of the curve. Okay, so the curve picture is here. Okay, so here's our favorite, quote unquote, y equals x squared fits this category. That would be p is equal to 1/4, I suppose. 4 times 1/4 is 1. So there's y equals x squared. Is vertex. Right now it's at the origin, but like this, we're going to move it somewhere. Focus, p units up, 0p. Directrix, p units down, but it's not just a single point, it's an entire line. And remember, for horizontal lines, the equation is y equals some constant. So in this case, y equals negative p. Okay, now, just take this picture, turn it like that, or turn it like that, or turn it upside down, and you have the other 3 forms. Okay, so if I turn this picture 180 degrees upside down, it looks like this. So this is x squared equals negative 4py. Okay. And again, what fits this pattern is y equals negative x squared, right? You can let p be 1/4. 4 times 1/4 is 1. Put the negative there, y equals negative x squared. Then you should already know, oh yeah, that opens down. Okay, so by analogy, the focus is always on the inside of the curve. So focus is now 0, negative p, and the directrix is y equals p. You're welcome to put all of these on your next cheat sheet. Right, so these are parabolas opening up and down. You should already be familiar with them. Less familiar are opening left and right. Okay, so let me show you those. So instead of x squared, but y is not, it's the other way around. Y is squared and x is not squared. So here's y squared equals 4px. Okay, squared and y, not x, opening to the right. Okay, but still the focus is on the inside of the curve. So focus is p, 0. So p units this way. P is used for the focal point. And p units this way, but again, it's not just a point, it's an entire line. So the directrix is x equals negative p. Y squared equals 4px. That's completely analogous to x squared equals 4py. You're just changing the x for y, and it opens to the right. And then how about opening to the left? There's a negative. Y squared equals negative 4px. Opening to the left. Okay. And the focus is always on the inside. So here the focus is negative p comma 0. Go p units this way and go p units this way. Draw this entire vertical line. The directrix is x equals p. So here are your basic 4 parabolas that we're going to deal with right now. To me, you sort of just have to think of this one. If you get this one down pat, right? Opening up, that's like y equals x squared. So y equals x squared fits this family, so to speak. X squared equals 4py. Focus, directrix. Okay, and then this one, I just turned this 180 degrees, and it goes down. If I turn it 90 degrees to the right, it looks like that. If I turn it 90 degrees to the left, it looks like that. That's what we're going to be doing in this section. That's essentially the parabolas. Okay. So a quick run through again. Definition of a parabola, which you don't have to worry about, but it's based on a focus and a directrix. So you're given a point and a line. Give me all the points that are the same distance away from the point called the focus and the line called the directrix. So like here and here, same distance, and a point way up here. This distance matches this distance, and so on. Okay, opening up, x squared equals 4py. P is the focal distance. Focus 0p, directrix y equals negative p. All of these are going to have the vertex of the origin unless we translate it. Translate again meaning move. Okay, what happens if I put a negative here? It will not open up, it will open down. Right? X squared equals negative 4py. Okay. So that means the focus is going to be 0, negative p. Directrix is on the other side, y equals p. Okay, turn this picture 90 degrees so it opens to the right. You got that. Y squared equals 4px. Squared and y, not an x, positive, going to the right. You can tell here x is not allowed to be negative, right? If you have a negative, you can't have y squared for real numbers. So the focus is p0, and the directrix is x equals negative p. And finally, turn this picture so 90 degrees so that it's opening to the left, and it looks like this. It's y squared equals negative 4px. Focus negative p0, directrix x equals p. And there we go. Okay, so x squared equals 4py, looks like this. If p is 1/4, you have our familiar y equals x squared. Okay. Now the translation, 0, 0, x plus 1 squared, we're going to get stuff that looks like that, equals 4p y minus 2. You know how the translation game works, right? 1 to the left, 2 up. So the vertex is negative 1, 2, 1 to the left, and 2 up. Okay. So that's where x is replaced by x plus 1, move 1 to the left. Y is replaced by y minus 2, I move 2 units up. Translation rules. Okay, and then just a little bit of physics, I suppose. So you don't have to take notes on this if you don't want to, but the idea of parabolas or parabolic dishes, and one of the reasons why it's called focus. Okay, so if you have parallel rays coming straight down on the parabola, it'll bounce off the parabola. Okay, according to the reflection law, the angle of incidence equals the angle of reflection. Okay, all of these will bounce and hit the focus. And it works the other way too. You could start off at the focus and you can emit, beams of sound or light or whatever. And if it bounces off the parabola, it'll all come out like so. Okay. It's my understanding that a lot of your headlights have a parabolic design. Okay, so you put the the light source, the light for your headlights at the focus. Okay, then you have this parabolic mirror here. So then the light hits the parabola, and then all the light rays will come out, which is the way you want it, right? You want to be able to see this way. You don't care about the light that way or that way. You want your headlights to shine so that it comes straight out. Okay, so it's actually a three-dimensional analogy. Three-dimensional paraboloid is what it would be called in three space, but the analogy is still there. So your car headlights, supposedly, you put the light source on the focus, make it hit the parabolic dish, and it goes this way. And speaking of parabolic dishes, right, there's some dishes, three-dimensional paraboloids, you have it set up at the focus. And same idea, you have radio waves or sound waves, right, that emanate from there, and they bounce off the parabolic dish to get, you know, what you need. Or it becoming the other way too. You get the rays coming from space somewhere, or you send out the ray and they bounce off the parabolic dish and then come in and hit the focus. So then it's all focused there, and then you can see the TV show or whatever, right? Okay. All right, so I'll get started with some of the problems, not many. I still have tomorrow to do that.
Can I ask you a quick question about something you were lecturing about? The translations, if it was y plus 1, like if the x's and y's were switched, like does the y like the y plus 1 is in reference to the y, so the y would be down 1.
Y plus 1 would be down 1, correct?
Like y plus 1, I mean y plus 1 squared. I mean, if it was y plus 1 squared equals 4p x minus 2. If it was the y would still be down 1.
Correct. The movement would still be the same. It would change what kind of parabola you have, right? So if you said the y was squared, then it's going to be either one of these. But we'll see exactly all those.
Okay, thank you.
Yeah. Okay. Sure. Okay, so 6.2. Let's see. We have to do what? 6.2, 1 to 35 odd. So let me go ahead and show that to you for those of you that don't have the book and aren't getting it. Kind of late to get the book now anyway. We're almost done. Page 325. Okay, so sketch the graph of the parabola showing the vertex, focus, and directrix. Okay, so there's 1 through 16, 17, 19. Okay. '21. 23 through 29. Let's see, how high did we have to go up to? 35. Okay, so there's 31, 33, and 35. Okay. All right, so I'll just start off with maybe 1, 2 problems, and that's about it for today. Okay, number 1, y equals 2x squared. I already know ahead of time that opens up. So I drew myself a little parabola. Okay, so I like to start off with drawing a parabola, you know, up, down, left, or right, just to tell me, okay, it's going this way or that way or whatever. Okay, so that means I'm going to try to make it look like x squared equals 4py. Force the equation to look like that. So multiply both sides by a half. X squared equals 1/2 y. Right, I just turned this over. Okay, I must make this look like 4 times something. So 4 times what number gives me a half? Okay, well, you're really just doing a simple algebra problem. 4p is equal to half. Right, so 4p equals a half. Multiply both sides by 1/4. And that gives me p is 1/8. So x squared equals 4p of 1/8, and then y. All right, so there we go. I know it's opening up. So vertex is at the origin. Vertex is 0, 0, so v for vertex. I go 1/8 of a unit up, which means the coordinates become 0, 1/8. Okay, these are not the scale. I mean, 1/8 is not that high at all. Then I go 1/8 of a unit down, but remember the directrix, which is a line, isn't just a single point. So I draw this entire line. And since it's a horizontal line, I need y equals blah, blah, blah. So y equals -1/8. Okay, so that's what I want for that one. All right, so one more time. I must make the equation look like this, or this, or this, or this. So they gave me y equals 2x squared. And you might say, oh yeah, I'm familiar with that. It's a parabola opening up and all that, which is still true. But in order to find the directrix and focus, I need to force it to look like x squared equals 4py. So I need to x squared isolate it. So I multiply by half. And then I need to say 4py is a half y. So 4p is a half. So I solve 4p equals a half multiplied by 1/4. So p is 1/8. All right, I was just going to show you one more, and then that's it for today. Okay, how about a negative? 9y equals -16x squared. 9y equals -16x squared. Okay, there's a negative, and x is squared, but not y. So that's going to look like this one. X is squared, not y, and negative. So it's going to open down. So I drew myself a tiny little parabola opening down. All right, make it look like x squared equals -4py. So first I divided by -16. You got to have just x squared. So x squared equals -9/16 y. And that just tells me it's a parabola opening down. And I want x squared to equal -4py, right? So -4p is -9/16. So I solve. So -4p equals -9/16. Multiply both sides by -1/4 to cancel the 9, right? So I get a very clumsy p of 9/64. So p is 9/64 in this case. All right, so I know it's opening down. Go like that. So I go 9/64 down. So the focus F is 0, -9/64. Then I go 9/64 up, but it's not a point. Remember, it's an entire line. It's a horizontal line, which has the equation y equals a constant. So the directrix, abbreviate little d, y equals 9/64. Focus is 0, -9/64. And the vertex is the origin. So when is the vertex not at the origin? Well, when you have a translation, a move, right? So let's see, 1 through 8, the vertex is all at the origin. But starting with 9, right? There's going to be some translation involved. And starting with 9, we have to do, yes, completing the square again. Remember that theme of completing the square? So we'll have to do that again. And I was going to start showing you stuff like that tomorrow. Okay. All right, quick word about 5. 5y squared, x is not squared and positive. So this one's going to open which way? Open to the right. Okay. Then how about 7 squared and y, not an x, and a negative? Go to the left. I guess that makes sense. I mean, one that goes up, one that goes down, one that goes right, and one goes left. Right? So it seems to be the most likely scenario. Go ahead and give you a heads up for Wednesday's quiz, which is very fast because we got a fast week. The most likely scenario for the quiz is I'll have you do 4 parabolas, just how they're going to turn. One up, one down, one left, one right. I want to be able to see that you can do them all. So I'll have you do one of each, right? One parabola that goes up. Well, I might as well write it in here. I already did it. So one that goes up. I already did number 1. I already did number 3 that goes down. And then tomorrow, one that goes to the right, one that goes to the left. And we'll do more of these other ones that are a little bit harder because you have to complete the square and stuff like that. Okay. So this one opens up. So how do I know it opens up? Square root of x, not y, and positive. Okay? Or just think, y equals 2x squared. From your knowledge before, you should say, oh yeah, that's a parabola that opens up. And this you should say is a parabola which opens down. Yeah, it's clumsy to find the P and all that, but that'll be it. Okay, and tomorrow I'll give you one that opens left and right, and then we'll do some more these things. Okay, so Wednesday, most likely scenario is I'll give you one of each of these. Parabola that goes up, down, left, and right. Okay. All right, I'm done for today, folks. So let me stop the share and check the chat if there's any questions, and if not, we're done. Okay, I don't see anything in the chat right now. So any questions, please? Otherwise, we'll quit. All right, that's it for today, folks. So have a good day, and we'll see you next time. All right, bye, everybody.
Thank you.
Thank you.
Thank you.
Thank you. Bye.